Okay, Chapter 8. We're in the subject of semiconductor technology. And we're going to begin by looking at basic atomic theory. And here we have a nice little atom with electrons flying around. A basic understanding of atomic activity is necessary to understand the operation and application of semiconductor devices in electronic circuits. Semiconductor devices such as transistors and diodes form the basis of nearly all modern electronic systems. And as we look at microprocessors and operational amplifiers, these are all devices that are built from these things that we call semiconductor devices. Classification of materials. Materials can be classified in many ways. One way of classification is into solid, liquid, or gaseous states. The materials in this section are all classed as solid state. One method of classification include electrical conductivity, color, density, hardness, resiliency, composition, and so on. We will restrict our discussion to classes of material according to electrical conductivity. So those are the types of materials that we will be looking at, and specifically they are insulators, conductors, semiconductors, and superconductors. Okay, review of basic atomic model. Atoms are comprised of electrons, neutrons, and protons. And so the neutrons and protons are in this area, and then the electrons are orbiting the nucleus. Electrons are found orbiting the nucleus of an atom at specific intervals based upon their energy levels. And what we'll find is that the electrons are orbiting the nucleus, and the farther they are from the center, the higher their energy level. And the electron out here, and this is we're looking at a conductor right now, and it only has one electron in the valence shell, and so the valence electron would have the highest energy. Okay, valence band electrons are the furthest from the nucleus and have the higher energy levels than the electrons in the lower orbits. And here we see this is the surface of the nucleus right here, and then we see the varying energy levels, and the closer to the nucleus, the lower the energy level, and it goes up until we get out again to the valence electron. The region beyond the valence band is called the conduction band. Now, this would be the highest level of energy while we're still in the atom, but if this electron here gains enough energy, it can actually go into what we would call the conduction band, and then it can become a free electron. Electrons in conduction band are easily made to be free electrons. Okay, this concludes the introduction to semiconductors.